as 42 kilonewton. Now next is to plotting of shear force diagram. Let us come over here. The given load value is 20 kilonewton per meter. Length is of 3 meter. This length is of 2 meter. This is my RA. The value of RA is 18 kilonewton and RB is of 42 kilonewton. Now, step number 1. I have to find out the shear force at each and every point. I have to plot the ordinate and I have to join those ordinates, and that diagram gives me shear force diagram. So now, first point, reaction itself gives me the shear force at that particular joint. So if I will take as a joint, so shear force at A is 18 kilonewton. Sign convention is important, plus or minus. So if I will take a section over here, section left upward treated as positive, so this is 18. Next rule, this is my joint C. Between A and C, there is no point load. Between A and C, there is not any kind of load. The variation of shear force is given by horizontal straight line. This is very much interesting over here. Next, SF at B, if I am interested to find out, the answer is known to me 42, but let us cross check it out, is equal to, because if I will take a section over here and if I will consider from the left side, then 18 plus sign minus 20 into 3, and this gives me 42 kilonewton with negative sign. So this is of 42, negative sign. How to join this point and this point? As UDL is there, recall the rule. For UDL, this has been joined by inclined straight line. Let's join this by inclined straight line. Now, whether this is right or wrong, then let us take a section. If you have a certain doubt, then in that case you have to take a section. Then our figure is like this. This distance is of x and this distance is of 2 meter. Then shear force at xx is equal to RA, that is 18, plus sign as section left upward, minus sign UDL is of 20 into distance, that is of x minus 2. This is equations having a value of x, and this equation shows us the variation is of inclined straight line. But even though if you have a doubt, then we have to put in this equation as x is equal to 0. Let us go for, if x is equal to 0, then SF at what place? See the figure over here. The distance x is from at A. This is the distance, this one x. So x is equal to 0. The shear force is at A is equal to 18 minus what is the value? 0 minus 2. SF at A is equal to 0, and this gives you 0, 18 value. Now if I will put x is equal to 2 meter, SF at C is equal to once again 18 kilonewton. So now next, you have to put x is equal to 3 meter, find out the value of shear force at 3 meter, and find out x is equal to 4 meter, find out shear force at 4 meter. And likewise you have to plot the ordinates and join these ordinates by inclined straight line. You will achieve inclined straight line directly. So this is my shear force diagram. Now this point is important for me, because the point at which the shear force is 0, we will able to obtain maximum bending moment diagram. So this point is important for me, because I want to find out this distance. How to find out this distance? So either there are two different options. Either take a section over here between C and B and equate it with 0. Another option, using the two different triangles, we can achieve the value of x. Let us solve this problem by both the ways, so that you will understand better way. So now, if we will take a section over here, shear force at xs is equal to RA 18 minus 20 into this distance, that is nothing but x minus 2, and this is equated with 0. Therefore 18 is equal to 20 bracket x minus 2, and we will achieve 18 by 20 is equal to x minus 2, and we found out x is equal to 2 plus 18 by 20. We found out some value. Now we can achieve the same value by taking the two different triangles also. So we found out the value of x is, this x value is 2.9 meter. So now let us go for bending moment diagram. So now see over here the shear force diagram. Variation is given by horizontal straight line, then inclined straight line, and the distance here 0.9 that you have observed over here, it is a distance between this point to this point. So overall distance from A to the 0 shear force is 2 plus 0.9 is equal to 2.9 meter. So let us go ahead for the bending moment diagram. The value is of 18 kilonewton. This value is of 20, and this is of 42 kilonewton. This is of 2 meter, and this is of 2.9 meter. The first rule at support A, this is support B, this is joint C, this is D point. So bending moment at A is equal to 0. It is known to us as supports value, the value is 0. Bending moment at C is equal to RA into 2. And if I will take a section over here, section left to clockwise, positive. So 18 into 2 is equal to 36 value, 36 kilonewton into meter. It is nothing but the bending moment ordinate. So this is my 36. Now after C point there is a UDL. So please remember this thing, that after C there is a UDL and the variation of bending moment diagram is given by parabola, and we know the type of parabola, and the value of maximum bending moment is also known to us, is at D. So you have a two option: either take a section at each individual 1 meter, at 1 meter what is bending moment, at one other next 1 meter what is bending moment, and then draw the ordinate, join that point and draw freehand diagram and plot it out. And another option, we know the shape, just plot it out. And this is nothing but by parabola. Here the shape Y has been drawn like this because this is my maximum value of bending moment. Maximum moment is there at 2.9 meter, the place at which the shear force is 0. So now our intention is to find out this ordinate. To find out those ordinate, RA 18 into 2.9 minus 20 into 0.9 into 0.9 by 2. This value gives me this ordinate. So look it out over here. The value comes to be 44.1. This value comes to be 44.1. So please see over here, the ordinate comes to be 44.1 kilonewton into meter. So this is the approach, the way at which we have to plot bending moment diagram. You can also plot this bending moment diagram by taking section at 1 meter interval. Take a section over here. So this is 1 meter, this is 1 meter, and this is 1 meter. Find out the ordinate at each point and join those points. But ultimately you have to find out the maximum bending moment at 2.9 meter because the shear force is 0, and that value comes to be 44.1 kilonewton into meter. So I wish you will be able to find out this BMD with ease and comfort. So let us go for the next problem. Now let us go for the combinations of the load and see how the variation of shear force and bending moment goes on. The given beam is of a simply supported beam with two different loads are acting. This 20, that unit is wrong, this is only 20 kilonewton point load, and the UDL having a value is of 10 kilonewton in per meter. And our intention is to plot the shear force diagram and bending moment diagram for given beam. So step number 1, we have to find out the support reactions. So for a given beam, this is the free body diagram which shows all the reactions RAH and RAV, and over here it is RB. By taking the step number 1, sigma h is equal to 0 and there is no external forces acting throughout the body, horizontal force, no single external horizontal force acting on this body, so RAH is equal to 0. By taking sigma v is equal to 0, total upward force is equal to total downward force. As per that, RAV plus RB is equal to 20 plus 10 into this distance. Distance is 3. So 20 plus 10 into 3, that is 30, is equal to 50 kilonewton. So we achieve an equation RAV plus RB is equal to 50 kilonewton by taking an equation sigma v is equal to 0. Let us go for the third equilibrium condition, sigma ma is equal to 0, and we will able to find out RB. So if you take sigma ma is equal to 0, the first force is of 20 kilonewton, creates a moment 20 into 1 clockwise positive sign at A. Another force 10 into 3 creates clockwise moment, creates a moment 10 into 3 multiplied by perpendicular distance. So perpendicular distance is the distance at which the load is acting. So if we will convert this UDL in terms of equivalent point load, so 10 into 3 acting at CG over here, 10 into 3, 30, creates a moment. So distance is 2 plus 3 by 2. So you just see 1 plus 1 plus 3 by 2 minus RB into 5, which is equal to 0, and by solving this equation we will achieve RB as 25 kilonewton. So by solving this, by putting the value of RB in this equation, we can achieve RAV as 50 minus 25 as 25 kilonewton. So we got the reaction RB as 25 kilonewton and RAV is also 25 kilonewton. So our next step is to plot the shear force diagram first. We go over here. This is of 25 kilonewton, this is of 25 kilonewton. Baseline 25 kilonewton upward, section left upward, plus sign 25. Between these two load there is no load, variation is given by horizontal straight line. So if you want to write down the steps, then SF at A is equal to 25 kilonewton positive sign. SF at C, this is my